your answer, because you know that whatever you did, so your that page you have uploaded, be ready with that. So I'll show you screen sharing and we can discuss regarding the doubts, okay, in that slot. That's fine. So let's start today. Today, let me share the screen. Uh, so
Sir.
okay. So
Yes, sir.
what I'll do quickly, I will cover what I want to recap what I told you last day. For area moment of inertia, basically related to area. This area mainly cross section. We are talking about the cross section, mainly cross section of any components. So like I have, say this way, I have one shaft and this is the cross sections. So I can put here these cross sections and maybe this is x axis, sorry, uh, maybe this is x axis, this is y axis, so this will be say z axis and this is cg, and we are calculating moment of inertia, area moment of inertia, ixx, iuyy, izz, then radius of gyration kx, ky, kz, then we are using some other axis, say like capital X, capital Y, then we are using parallel axis theorem for this, say Ixx equal to I small xx plus area multiplied by distance, say d1 square, and so on. So for doing that, we have derived there are some special cases like pressure which is varying with respect to some distance, sometimes bending stress or torsional stress, and we got finally expression that y squared dA some distance squared multiplied by area, like some distance square, uh, distance square multiplied by dA elemental area, integration of some with integration, those values or those parameters, those expressions are important. Then we got ixx, iuiui, izz, then relationship izz equal to ixx plus iuiui. Radius of gyration also we have got relationship, parallel axis theorem. Then we got this, if this is the rectangular one, this is the base, this is the center basically, then it is 1 by 12 base multiplied by ACI GH height cube. This is the relationship we got, say I x0. Double x, somebody, sometimes we can write this. But when we are talking about with the base, this is IXX, it was 1/3 multiplied by base multiplied by height cube. That is, we have shown that there. Now when it is circle, sorry, is triangle, triangular shape, cross sections, what we have learned that if this is the CG, so this is the CG locations. So say x0, x0, CG location, then we got IX0, x0. With respect to CG, it is, let me show you from there. When it is base, it is this. When it is CG, it is BH cube, base height cube by 36. And at this base, basically here, it was 1 by 12 BH cube. And we know that parallel axis theorem, two things we have to be careful that axis supposed to be parallel. Second is out of two axes, between two cases we want to compare, one must pass through CG, because derivation says that parallel axis theorem we have utilized this expression and this value was 0 and this is sorry this is passing through centroid. By definition this value will be 0. Then for circular one, circular cross sections, for circular cross section, last day we have told that this IZ, sometimes we wrote J, polar moment of inertia, that is pi r power 4 by 2 or pi d power 4 by 32. And Ixx due to symmetry will be same as Iyy, it will be pi r power 4 by 4 equal to pi d power 4 by 64. Then given the cross sections, what we have to do, we have to use the proper cross section to calculate the elemental cross sections to get the dA. Then it will be y squared dA or x squared dA. You have to be careful. Say when we are talking about this one, then directly it is y squared dA. But in this case, this element's center is here. So we will put this type of relationship in that case. Actually, x elemental and y elemental, that square we have to take. Okay. Then composite area, different area we have, we can have this type of addition. Then product of inertia, important for unsymmetric cross sections. For unsymmetric cross sections, this will not be 0. For any symmetric cross sections, it will be 0. But what we have learned that when we are transferring the axis, even it is symmetric, say it is symmetric, but when we want to transfer this with respect to say x and y, and I x cg equal to 0, sorry, x y cg equal to 0. But when we want to transfer using parallel axis theorem, if it is distance a, this distance b, and this area is a, then I x y, just a minute, just a minute, hold on. Okay, so that will be I x y c g plus area multiplied by a multiplied by b, and this one we know 0, then that will be a multiplied by distance a multiplied by distance b. Okay, capital A is the area. Okay, then when we want to transfer or rotation of the axis, not transfer we have told before, rotation of the axis, we have seen that in with some degree, say theta degree rotations, we have Ixx prime, Iyy prime related to these expressions for maximum and minimum value, and this is the tau xy, product of inertia. For to get maximum of minimum value, this is the expression. Alpha is reality, in mode circle it is twice alpha, because when we have derived this expression, basically this theta, basically here it is theta, will become twice theta. Here it will be twice theta. So if I want to draw the mode circle, theta will be in mode circle twice theta. This is the maximum value, this is the minimum value corresponding. Theta we call the maximum, actually principal axis. We call principal axis. Principal axis. Principal axis. Now, how to draw the motorcycle? If we calculate Ixf, you know, say for example, Iyy, Ixy. To draw the motorcycle, we have one I rectangular moment of inertia axis, and this is product of inertia axis. We can put this value, say Ix's value is this, then some Ixy value is this. So this is Ix's value and this is Ixy value. And maybe we have Iyy value is this. This value is Iyy. Iyy. Then with this to this, the 2 points, there will be one center. So draw this with this center, draw this circle. If you draw this circle this way, then what you will get? You will get here I minimum, and here it is, this distance will be I maximum. And this I, this is the principal axis, we call principal axis. And you can understand from this, if you extend this like this is theta, theta. Actually not theta, it is actually 2 theta. This is the 2 theta. So 2 theta degree variations, and we know that this tan 2 theta equal to minus 2 Ixy by Ix minus Iy. Or minus you can put here Iy minus Ix, or write Xx and Yy. And you can clearly say, check that it is clockwise direction. Clockwise directions movement. That's why theta was negative here. Once we'll solve the problem, we'll understand. So this way we have to get from principal to get principal axis directions and I max, I minimum value. Okay, and this will be used for this is called mode circle. Mode circle. And this mode circle will be used further for strength of material, where this Ixx will be replaced by sigma xx, Iyy will be replaced by sigma yy, and Ixy will be replaced by shear stress tau xy. So that one you will learn in higher classes. Now, given the problems, we can solve whatever will ask you. Some standards property you can get from the appendix books. Now, this is the portions of the theory is over. Now, question is related to problem sheet. Okay. Now, what I can do, if you see our calendar, this February is gone. For the March, I think your exam will start from something here. Let me check from the mobile also. End semester date will be 7th. From 7th March, sorry, 7th April, your end semester supposed to start. So, and there is one holiday due to Holi on 18. So, I will be getting 1, 2, 3, 4, 5, 6, 7, 8, 9 days next week. Okay, 9 days. Out of that, one day can be one class test. Maybe here, one day will be for a recap. If you have any doubt, problems, we can discuss on say 1st, April 1. So 29 maybe your another class test. So I am getting 1, 2, 3, 4, 5, 6, 7 days. So I am getting for next week onward 7 days. To for dynamics, I have problem sheet. Total number is 9. 9 problem sheets I have to complete within 7 days. Okay, 7 lectures. So lectures. So I am in a very tight schedule. So I cannot give you any extra day for statics apart from today. Now your question, you tell me what are the problems you are facing to solve. Yeah, let me know. You tell me first, then I will start moving.
9, 10.
Just a minute. 6.1,
9 and 10.
9 and 10. Okay. 9 and 10. Okay, anything else? Anybody, other students want to tell any problems you are facing? 6.1? No. Okay. And 6.2? 6.2? Have you started 6.2? Any student?
No, sir, we haven't started
Okay.
6.2 yet.
2, 6.3. Okay, no problems. So what I have planned, so 6.2 and 3, all problems hints I have to provide, or else you will not able to solve. And 9 and 10 I will cover. Apart from that, some other problem also I want to cover now.
Sir,
So
6.1 number 2, sir.
6.1 number 2. Okay. Any other problem?
No, sir.
Okay, fine. So I will give you the hints for almost all problems. Apart from today, there is no chance to discuss regarding moment of inertia or any static parts. Only I kept one day, that is April 1st, Friday, as I told, April 1st. Yes, what it is. This one Friday I will get for this. Okay, all chapters if you have any ambiguities. And 29th will be your another class test. Okay, remaining 7 days for dedicated for dynamics. Now let me give hints to solve this problem. Say 6.1 number 1. It is given that ring has some area, A value is given 1600 millimeter square. You have to calculate moment of inertia of the ring with respect to x-axis to a close approximations. So you have to calculate Ixx value with the close approximations. Somebody can try this way also, that if you know this Izz, that is related to its area multiplied by distance square, then 1600 multiplied by 100 square. This is millimeter per 4. This is Izz. And due to this symmetry, somebody can not symmetry, we know this one, this relationship is always valid. Ix is equal to plus Ixx plus Iyy equal to Izz. And if you want to take respect to x or y, it is same due to the symmetry. So Ixx will be Izz by 2 and you will get the answer. Is it okay? Question number 1?
Yes, sir.
Yes.
It's very
Now
simple.
2. Yeah.
But I done a little bit
So
by taking.
in other approach also you can do, no issue. Okay, don't worry. Have
Yes,
you got this answer?
yes, sir. Yes.
No problem. Multiple way we can do. Now somebody asked that you are facing the issue for problem 2. We have to calculate the moment of inertia of the shaded area about the y-axis. So you have to calculate Iyy about the y-axis. Now to solve this, whether what you want, horizontal strip or vertical strip? Any guess?
Vertical strip. Sir, vertical.
Okay. Vertical strip, there is only
The
one.
horizontal may be easy to solve.
Yes,
No, the
vertical
horizontal
strip
strip.
issue
The
is, yes.
horizontal strip.
Yeah, vertical strip, one issue is to calculate this area. It is so idea is whatever the strip you will take, it should able to capture that total area correctly. That is better. We can do, but it will be little bit complicated. So let's take horizontal strip in that case. Any horizontal strip we can take. So remember, nothing is FBD. It is not FBD, not free body diagram. We are talking about the cross sections. No force is involved, so it is not a free body diagram. Okay. So horizontal strip. So if I take horizontal strip this way, and maybe from this to this distance, it is at the center. Okay, it is y, and this distance is dy. So dA area will be, what is the area? That will be x multiplied by dy. This is the area. Is not it? Now, if somebody is having this dy, and of course this distance will be, x. So it is looks like, you have one element. That element looks like a rectangular element. So somebody can write this way: the diy equal to one third, because with respect to base, correct? One third base multiplied by height cube. So one third, here base is dy and height is x cube. Okay. So this is the expression basically. This is the diy. So what is the relationship given? This x square equal to 112y. So x equal to square root 120 square root y. Is not it? So here it is one third multiplied by 120 power 3 by 2 multiplied by y power 3 by 2 dy. Okay. So somebody want to calculate, then IYY, just simply do the integrations. Y is varying from 30 to 120. You will get millimeter per 4. Final answer. Okay. Have you understood now? This problem can be
Yes,
solved
sir.
easily.
Understood, sir.
Yes, yes. This is done. 2 is done. Then just I will give you the hint. Say for 3, we have to calculate moment of inertia of the rectangular area about x-axis and find polar moment of inertia about O. This is the O. Okay. So polar moment of inertia about the x-axis rectangular area. Okay. So it is Ixx will be one third multiplied by base multiplied by height cube. Okay. One third base is 60 multiplied by 100 cube, millimeter per 4. This unit is important. Always you have to write the unit. Okay. Now, if I consider this is another axis, so it is y0 passing through centroid. This is passing through centroid. Then I y0 will be 1 by 12, base is 60, base is 6, the y, correct, base 6 is 60 multiplied by height cube. One minute, I did one mistake here. Okay, Ixs was this, base was 100 and height was 60. Okay, so base multiplied by height cube was Ixx. Okay. Now this IYY with respect to this, as this is the centroid, it is 1 by 12 multiplied by base multiplied by 100 cube, millimeter per 4. Okay. Millimeter per 4. So we got IYY, Y0, Y0. And we also know that at centroid we are getting the minimum value, and IYY will be I Y0, Y0 plus A multiplied by distance square. So IYY will be IYY Y0, Y0 plus area 16 multiplied by 100 multiplied by
5
distance.
square.
Huh? It is how much?
5 square.
No, it is, the distance is 100 by 2. This is 100 by 2 minus
25.
25. 25, correct? So 25 square, is not it?
Yes, sir.
Yeah. So whatever value will get, then Iz will be Ixx plus Iyy. iz respect to o, izo. Actually, we have already converted here, correct? So you can get the value. This is done. Number 4, determine the polar moment of inertia of the semicircular area about point A and B. About point A and B. So what we will do? So if somebody want to calculate that iz value for this is r. So this is r0, t r0. Then j basically integration over this r0 square to twice pi r0 dr0 by 2. This was the formula. Here it was 0 to r. If I use this one directly, basically we will be getting that value as pi r power 4 j. It was 2 for full, half is this. This is the j value. For half circle, we can calculate j value from the first principle. Pi r power 4 by 4. Now, what is the location of CG? This is the CG locations. If I write this distance r bar, that is 4r by 3 pi. You know the location of this, correct? 4r by 3 pi. Let's consider or think this point is C. This point is C. That means I xx. If it is j is this, then we can calculate Ixx equal to j by 2, j by 2. Okay. Or in terms of j also we can move, no problem. I will write here. This, wait. This is j, this is 0, correct? This is j0 will be jc plus a r bar square. That relationship is valid, correct? Because we know at the centroid value is minimum. So J0 will be Jc plus a r bar square. This is the r bar. Then Jc you can calculate this Jc. Then similarly you can calculate Jb equal to Jc plus a multiplied by r minus r bar whole square. Then you can get the b value jb. For a j will be jc plus a multiplied by this distance. Okay, what is that distance? That will be plus r square plus r bar. This is r bar square. Is not it? So you can easily calculate j value and jb value. Later I am writing this is a j polar. Let it be j. Have you understood this point, or should I explain once?
Understood.
Yeah. So what we did, first of all, j value we have calculated for half circle, then we have moved j to centroid. J0 to j centroid, jc. Then jc2 we have to move jb, then ja. Why? Parallel axis theorem is only applicable between two axes. Those are parallel, and one needs to be passed through CG. I cannot move directly. I cannot write this is JA equal to J0 plus AR square. JA equal to J0 plus AR square. I cannot write because this is not the centroid. Now centroid is C. 4 is over. Then 5. For 5 polar moment of polar radius of gyrations. So what you have to do? You can write this way. So one triangle, two triangle. For one, say with respect to M, midpoint M, you have to calculate. So maybe you write this is the X, this is the Y. Then easily you can calculate Ixx value for this triangle. Iy value will be 2 times this value, this one. then you can get J, and you can calculate moment of polar moment. You can calculate K value. Okay, area you know, half multiplied by base A multiplied by height. This height will be,
Root 3a by 2.
yes, root 3a by 2. Root 3a by 2. Then you can calculate this value. Now somebody ask question number 6, nobody asked, no problem. You have to calculate the moment of inertia. You have to calculate the moment of inertia.
And what's the shaded area?
Oh yeah, shaded area is this. Okay, okay. Moment of inertia of the shaded area about the x-axis, about the x-axis. So Ixx you have to calculate. Let me change the color. Okay. So we have to take we have to take that strip, small strip, such that it's supposed to pass both x-axis, sorry, both the curves. So which one do you want, vertical axis or horizontal axis? Which one do you prefer?
Vertical, sir.
Vertical axis. Okay, you can take vertical axis also. We can take vertical axis like this. Okay, vertical axis like this. Okay, so if you take vertical axis, then for small strip, this is a dx, so this is a x. Okay, this is basically up to middle x, and you consider two things, two graphs we can consider, graph 1 and graph 2. Maybe this one graph 1, this is graph 2. Okay, so somebody can approach this way. One is this triangle, sorry, this rectangle, other is this small rectangle. You can consider this way, correct? Bigger triangle and lower triangle, and you can use this one, integration of 1/3 base dx height cube. Height cube means y2, y2, it is y2 here, cube, minus 1/3 dx y1 cube. What is y2? Y2 is this, y cube x equal to ky cube, y equal to, okay, y cube, correct? So here y cube will be x by k, x by k. It is also passing through the point 40 comma 30. You can get the value of k. Okay, so what we can write, 1/3 y cube is, so 1 by k x dx. Okay, integration over 0 to x value up to 40 minus 1/3. What is second one? This is y equal to mx, correct? Y equal to mx, it is passing through the point 40 30. So 30 equal to m, 40, m equal to 3 by 4, m equal to 3 by 4. So it is 3 by 4 x dx. Okay, sorry, cube I forgot here, this x. So what I got here, x equal to, sorry, x equal to 4 by 3 y. Actually here it is y equal to 3 by 4 x, 3 by 4 x. So you can, integration is 0 to 40. You can do the integrations, or maybe you can try with the horizontal strip, or maybe you can try with the horizontal strip like this. This is the horizontal strip, and this is y. Let me change the color. This is y, and dA equal to x1 minus x2 multiplied by dy. So x1 value you can write, x2 value also you can write. Here x1 value is 4 by 3y, 4 by 3y minus x2. X2 will be k y3 dy. Then ixx will be integration y square dA. That means 4 by 3 y minus k y3 y square dA, integration of y equal to 0 to 30. Okay, if you do this you will get the same value. 6 is okay for you, either
Yes,
approach
sir.
you can do. Yeah.
Yes,
Now, yeah, now 7. For determine the moment of inertia of the shaped area about the x-axis using horizontal strip and vertical strip. Yeah, somebody can take this horizontal strip, then dA will be, this is horizontal strip means this is x, this is y. I am giving the hints only, you have to do carefully. Okay, dA will be x dy, this is dy, so y square dA. And if you take the vertical axis, this vertical axis like this, dx, this is y, then you will use 1/3 integration of 1/3 y or dx y cube. You convert it and you will get the results. Done. 8 is determine the moment of inertia of the shaded area with respect to x and y axis. Use the same differential element for both cases. Let's take the vertical strip. This is the strip you can consider. So this equation 2, this is equation 1. Okay. So so y equal to mx. This point is a comma a. So this is a equal to m,
sir.
m
Y
equal
equal
to,
to X, the line would be.
yeah, m equal to 1. Okay.
Yeah.
Now I am using this. So I am satisfying a, m equal to 1. You are right. Y equal to x. Okay. So this is y equal to x. Now for this vertical strip, I x x, what is dA? dA is, dA will be, dA will be, this is dx, this is x, this is y, dA will be y dx, y multiplied by dx, that will be dA. Okay, so y multiplied by, actually instead of y I should write this is y2 minus y1, is not it? Y2 minus y1. Y2 is, here it is y2 equal to x minus y1. This one, this y1 is x square by a, this dx. That is the dA in terms of x.
Yes, sir.
Yeah. So in terms of x, it is dA. Now IYY equal to x square dA integration. So x square, x minus x square by a dx. This integration with x is from 0 to a. You can get IYY value. Now for IXX value, we'll use in other approach. What? 1/3 integration 1/3 dx multiplied by y2 cube minus 1 y1 cube. It is better. You directly put the value expression of y1 and y2, you will get IYY. Have you understood this problem properly?
Yes, sir.
Yeah, we can do this. Now question number 9. Somebody I think asked question number 9. Yes. Determine the moment of inertia of the shaded area about the y-axis. As I told, I can take this strip vertical or horizontal strip. If I take vertical strip, it is not cutting both the curve properly. That's why it is recommended to take horizontal strip. It will be very easy for us to solve this. So erase this. So what we'll do? Will you write this one is y, this is dy, and this point is 40 comma 40. So x equal to ky square. 40 equal to k 40 square, k equal to 1 by 40. We got the value of k. Okay. Now, now for this one, what is this curve basically? What you want to write? Let it be curve equal to y equal to mx plus c. It is passing through 2001.
Sir, one is parabola, another is straight line.
No, this parabola we got, this k value we got. Now is this straight line. This k value we got 1 by 40. Actually, the x
Sir,
equal
there
to
would be some C, sir.
y equal to mx plus c. Okay, that is y equal to mx plus c, is not it?
Yes, sir.
Then it is passing through this point. This is 20 0, and this point 40 40. So you satisfy with that value. Okay, if you satisfy with that value, you will be getting c value equal to minus 40 and m value as a 2. So your y will be 2x minus 40, or x will be 20 plus y by 2. Any formula you want, you can use. Okay, x and y. So you got the straight line formula and the parabola formula. Now you give, this is say 1 and this is say 2. Maybe we'll change this. So our target is IIY, is not it? So we'll write this is the, so this is the small strip up to this. This is the small strip. Okay. So directly we'll write IIY equal to integration of 1/3 of what this is. So if I write this one, this is basically x1, and this you have to write carefully. Okay, good pictures I want. This is x2. So 1/3 multiplied by base dy multiplied by height cube. So x2 cube minus x1 cube. So integration of 1/3 x x2 x2 means, let me check, this one, correct? X2 means it is 20 plus y by 2 cube dy. Y is varying from 0 to 40 minus 1/3 0 to 40 y cube x1 cube. X1 means this, that cube, it is y square by 40 cube dy. Okay, so if next will be, you have to do this integration properly. Okay, you have to integrations properly, you will get this value. Is it okay? 9. Somebody asked
Yes,
problem
sir.
9. Is it okay now?
Yes.
Yeah.
Yes, sir.
Now 10. Calculate the moment of inertia of the overlapping shaded area. This is the overlapping shaded area of the two circles about x-axis. I-axis we have to calculate. Let me erase this. I need some space. Okay. So about x-axis. Okay. So if I draw this, let me try this drawing. This this is the center. This is the center. You can draw using your geometry box for this type of problems. I am drawing roughly here. Okay. So our interest is intersection area. This is x and this is y. IXX we have to calculate. So what you can observe here for intersecting area, maybe this color I will take. So this is the elemental strip. This is the elemental strip. Okay, and this value is x1, this value, and this is say x2. This is x1 means this is 1 and this is 2. This is x1 part of 1. This is x2. Okay, and maybe consider this is y and this is dy. So IXX equal to integration of y square dA. Okay. Now this dA equal to x2 minus x1, sorry, x1 minus x2 multiplied by dy, is not it? For small element looks like rectangle. Okay. x1 minus x2 dy. Okay. Now let's concentrate on the value of x1 and x2. There are two circles basically. Circle 1, if circle 1, this is the center. What is the center? 0 minus r by 2. Radius r is given. And for this center is, just a minute. So okay, let me concentrate this one. First of all, this is 0, 0, this point, and this point is, this is x is r by 2 comma 0. Okay, and this one minus r by 2 comma 0, this point. Okay, that means for this one, for equation 1, circle equation 1, it is x minus r by 2, means x by r by 2 whole square plus y square equal to r square. And for equation 2, it is x minus r by 2 whole square plus y square equal to r square. From this, you can write this x1 equal to minus r by 2 plus minus square root r square minus y square. Here I have intentionally I have written here x1. Okay, x2 equal to r by 2 plus minus square root r square minus y square. Now question is whether you want to use plus minus or only plus or only minus. Can you tell me? Whether you want to use this plus minus sign or only plus or only minus. In your figure, x1 value is positive or negative?
Positive and x2 is negative.
If it is positive, then which one you want to use, plus or minus?
Plus. Plus, sir.
Plus.
Okay, and this x2 is negative or positive?
Negative. Negative, sir.
Then definitely you want to use minus sign. Okay. If it is so, then x1 minus x2, maybe equation 3, equation 4. Okay. So x1 minus x2 will be, this will be cancelled out, correct? No, it will be added, correct? So it will be added. Then it will be
Yes,
2
sir. Added.
square
Yes,
root,
sir, added, sir.
r square minus y square minus r. Okay. So this is x2 minus x1. So here finally this value will be 2 square root r square minus y square minus r dy. That is dA, correct? Now, yeah. So this value will be, this will be IXX will be integration y square 2 square root r square minus y square minus r dy. Y is varying from, what is the y variations? This value. What is this value? Okay. So you can consider this way. This is
Root 3 by 2.
okay. This is r by 2. Okay. Okay. And this is r. And what is this value? Okay. So this value you can calculate root 3 by 2 r. Okay. So 0 to root 3 by 2 r. You calculate and you will get this value. Okay. Should I explain once again? Is it clear or I should explain once again?
Sir, explain once
Sir,
again.
clear, sir.
Yes. It has been asked that calculate the moment of inertia of the overlapping shaded area of the two circles about the x-axis. About the x-axis means IXX we have to calculate. And it has been given in this problem. This is the x-axis, this is the y-axis, this is the intersection. So this is supposed to be 0 point. And this point is supposed to be r by 2 because this is a center. This is also center r by 2 0 and this is minus r by 2 comma 0. Now this is the part of the circle, say circle 2, this is circle 1. For circle 1, center is minus r by 2 comma 0. For circle 2, center is r by 2 comma 0. Now the equation of the circle 1 will be x minus r by 2. That means x plus r by 2 whole square plus y square equal to r square. R is the radius. For second case, it is x minus r by 2 whole square plus y square equal to r square. Now x1, for 1 I wrote x1, for 2 I wrote x2. Minus r by 2 plus minus square root r square minus y square. Here r by 2 minus plus square root r square minus y square. This figure says this is x1, this is x2. x1 should be positive. That's why we have used plus here. X2 should be negative. That's why we have used negative here. Now if it is so, then x1 minus x2 is straightforward. It is 2 square root r square minus y square minus r. Now for this IXX equal to y square dA. dA equal to x1 minus x2 multiplied by dy. I have just used the expression of y square here and this is x1 minus x2 and this is dy. What is the integration point? Variations. What is the integration variations? This varies for y value only. Okay. For y value only. Okay. I missed one thing. If I used, so this value we got. This value we got square root 3 by 2 r. Now if I use this section, half section, 0 to square root 3 by 2 r and we can multiply it with 2 and this is 0 to this value. That we can do. Okay. So we are multiplying using multiplied by 2 because there are two symmetry sections. Now somebody can ask why not we can use minus square root 3 by 2 to r. That also you can try. Okay. That also you can try. It's supposed to have the same value. But for simplifications, we want that these two are symmetric, so it will be 2 times of that. We have to be careful here. Integration is many times. No, that area it is having only summations, algebraic summations. Okay, of the two sections. That's all. Is it clear now?
Yes,
Yes,
sir.
sir.
Yeah.
Yes, sir.
Okay, fine. Just let's take water, then I'll tell you. Just 1 second. So we have done with 6.1. Now moving to 6.2. This is the area moment of inertia of the composite figure. So the way you have calculated CG, centroid, for composite area, here similar approach we are using for moment of inertia of composite area. Say for example, this one, calculate the moment, polar radius of gyrations. polar radius of gyrations of the area of the angle section. This section is known as angle sections. In many aerospace applications, civil, electrical application, metallurgy, mining, these sections you can see. Basically, let me tell you this way. You will understand. Say this sections, correct? So have you seen this type of sections in reality?
Yes, sir, I've seen them.
Yeah. That section basically. So this cross section becomes this. Okay. So this is a sectional area. Okay. Now, and this type of section will give very good resistance against buckling also, bending also. Because for torsion, generally circular cross section we used to calculate, we used to consider, but this will give good amount of resistance against bending, against buckling, compressive load. Okay, so now we can note that width of the legs are small compared with the length. Okay, so the width is like 30, other is 300. Ratio is 10, correct? And we are using 1/3 of base multiplied by some cube. Okay, so definitely that the value which one is lower, that will impact will be less in total value. Now, if I want to calculate polar radius of gyration, so let me write J Ixx plus Iyy. Why I am using J? I know it is Izz, but J if I write it is better. It is indication is something different. Polar J. Okay. So if you do so, so this is X and so this is Y. It is X and this is Y. You consider for Ixx here for Ixx. So base is for this case base is 40 multiplied by 30 cube. I'll tell you here. Say it is 1 by 12, base is 400, sorry, this is 400 and this is 30 cube for case 1, okay, and this is 2. Let me write this way, Ixx 1 and Iyy 1 for this case basically. With respect to this, 1/3 base is 30 multiplied by 400 cube. Everything will be millimeter power 4, okay, power 4 unit we have to give. Now for this case 2 Ixx2 means this one with respect to xx 1/3 multiplied by base multiplied by height cube 300 cube and Iyy2 equal to 1 by 12 multiplied by base 300 multiplied by height cube. You have to be very careful. When I am using Ixx here 1 by 12 I have considered because this is the centroid. But when I am using Iyy1, that is Iyy, this is the y directions. Then I have used 1/3. Be careful. When it is centroid for rectangular sections, 1 by 12. When it is base, 1/3. Now you can consider that this value is very less. This 30 cube, this value is very less compared with this value and this value. That's why somebody can write J is approximately 1/3 of 30 multiplied by, just a minute. Okay. So 1/3 30 multiplied by 30 cube plus 1/3 multiplied by 30 multiplied by 400 cube. This is millimeter power 4. That is more. This assumption is okay for us. Now what is total area? E1 plus A2. A1 plus A2, and maybe if I use this summations, it is 910 multiplied by 10 to the power 6 millimeter per 4, and A1 plus A2 is 30 multiplied by 400 plus 300. Okay, and if you use then k value square root I or j by a, you will be getting 208 millimeter. J is millimeter per 4, A is millimeter square. So you'll be getting 208 millimeter. So that way you can do these problems. Okay? Is it okay? Problem 1. You can use a detailed one, you can approximate also. Is it fine? Polar moment of inertia. J equal to A, or maybe this way we can write J equal to K square A. That relationship we are using, or KZ here. Is it okay?
Yes, sir.
Yes,
Okay,
sir.
next problem. Problem 2. Okay. Determine the moment of inertia. Determine the moment of inertia of the Z sections about the centroidal axis here. This is the centroidal axis. This and this. You have to calculate moment of inertia Ix and Iy with the centroidal axis. Fine. So you divide this. This is 1. Okay. We want to divide into 3 parts. This is 1. This is 2. And this is 3. You divide this into 3 parts. Now, let me erase it. Some space is required. I'm giving hints in exam. If I asked, you have to elaborately solve this, and you can expect one compulsory questions. So maybe we can ask 4, 5, 6 questions. Say one question will be compulsory. That will be moment of inertia. No escape. Okay. So for this problem, for part 1, part 1 is something. It is passing through centroid itself. So we don't need to use any parallel axis theory. So for this case, Ixx 1. This is x or x0. This is y0. So this is Ixx will be 1 by 12 multiplied by base. Base is 20. 20 multiplied by height cube. Height was, here it is 140 plus
100.
60. No, this is 140. This to this 140 plus 20. Sorry, 140 plus 20 cube. You just check whether I am right or wrong.
Yes, sir. Yes, sir.
Yes. You have to write in details like this. Okay. Ixs. So Iyy1 will be 1 by 12 multiplied by base 140 plus 20 multiplied by 20 cube. This is right, millimeter per 4. So this is the for 1 Ixx and Iyy. Okay, and it is located at the centroid itself. Now for part 2, Ixx2, for this 2. Okay, so you can imagine this is the centroid. I am writing here. This is the centroid. Imagine with respect to centroid, we want to calculate something, then we will use parallel axis theorem. So x-axis parallel, y-axis parallel, that way you can consider. So this will be 1 by 12 multiplied by base. Ixx, correct? IXX means this is X. Base will be 100 minus 20. This is 100 and this is 20. Base multiplied by height cube, 20 cube. That is with respect to centroid plus AD square. What is the area? 100 minus 20. You just check, I am not using any step jump. Multiplied by 20. So this is the area multiplied by distance square. Distance square of the from the x axis, that is 20 by 2. This is the 20 by 2 square. That is the IXX. So 1 by 12 base multiplied by height cube plus area multiplied by distance square. Then for the same part, IYY2 will be 1 by 12 multiplied by base is 20 multiplied by height cube. Okay, plus area 100 minus 20 multiplied by 20 multiplied by distance square. Just a minute, just a minute. Okay, I did one mistake. Yes. So this was 10. This was 20 by 2 is fine, but I missed this part. I missed this part, this distance. This distance. This distance I missed. Understood? I told this, I have told here this distance. That is fine. This distance plus this distance I have to add. Which distance? Let me tell you this distance. So our this total distance supposed to be this distance. So that is, let me check. We know that total was 160 and this was
20, sir, I think.
Wait,
60.
let me check. This is basically 160 by 2. Okay. This was 160 by 2. 160 by 2 means 80. That means this is 80. Then this was 60.
Yes, sir.
80. This was 60. So this plus 60 squared. Okay. Now it's okay. 70 square basically. You see them. That's supposed to be one total 180, then 80, and this 20, 60 plus 10, 70 square. That will be the expression. For this case, distance will be 20 by 2 plus this was 80, 80 by 2 whole square. This is 200, this is 80, 80 by 2 square. Let me check once again because I can do some mistake here. This is basically 70. Yes, 70 square and this supposed to be 10, 50. This is 40, this is 50. Yes, this is 10 and this is 40. Yes, yes. So you can get IYY2. Now, if you consider part 3, this part 3, you can check that for part 3, although this is Z section, whatever IXX2 you got, value will be same for part 3 also, because with the centroid I value is same, IXX and IYY. Area is also same, distance is also same from the x axis and y axis. So part 3 IXX3 will be IXX2 and IYY3 will be IYY2. Now what you have to do? You have to calculate I equal to IXX1 IXX2 plus IXX3. This is IXX. IYY will be IYY1 IYY2, IYY3. Then you will be getting this answer. Have you understood? Or should I explain once again? What I did, I have split the sections into three parts. Part 1, part 2, part 3. And everything I am calculating based on the centroidal axis x0, y0. So part 1, it is one third base height cube in x with respect to ixx and iyy. Centroid locations, no parallel axis theorem addition is required. For part 2 and part 3, which are same, its area are same, distance are also same from x axis, x0 and y0 axis. So ixx for 2 and 3 will be same, IYY for 2 and 3 will be same. Let's start with any of the case, either 2 or 3. I22 will be elemental Ix2 will be elemental Ixx for 2 plus a distance square. Area multiplied by distance square. Very carefully you have to take the cross. You have to see the sections, area, distance, and whatever base and height you calculate and do the and calculate this Ixx and Iyy value. Total Ixx with respect to x0 will be summation of 3 Ix x and Iyy with respect to y0 will be summation of these three parts of Iyy. Is it clear?
Yes,
Yes,
sir.
sir.
Okay. Next.
Yes, sir.
Yes, yes. Determine the moment of inertia of the shaded area about the x-axis. Which one is shaded area? Shaded area is this.
I see.
Yes, I sections. So as I told, many places in electrical engineer also have seen this I sections. Okay. So to solve this similar way, we can divide this into three groups. Okay. Say this is 1. This is also 1. Let it be same. And this is 2. So Ixx2 will be 1 by 12. This is A. Height is 2A cube. Iyy2 will be 1 by 12. Base is 2A and A cube. Ixx1. Everything we are calculating with x. Okay. Oh, here it is been asked only x. Okay, don't worry. Iyy is also not required then. Ixx1 will be 1 by 2. You have to be careful. We are not using one third with respect to base and this distance we are not using because if I use this base, say one third 4a cube, then a d square. If I use, it will be wrong because base is not passing through centroid. That's why imaginary centroid we are considering here. We are considering here, and this to this distance we are calculating. So Ixx1 will be 1 by 12, base is 4a multiplied by height cube plus area 4a multiplied by a multiplied by distance square. Distance from x axis a plus a by 2. A plus a by 2 whole square. So this 1. So if this is the total value, I will multiply it by 2 for both sections. Then you can take the summations, you will get the value of I. And if it is something a power 4, you can write this way, unit power 4. Or maybe if it is millimeter power 4. In midsem, somebody missed the unit. I have deducted 1 marks for each case, not writing the unit. Say somebody got some Newton, but unit you have not mentioned. Should I assume it is Newton, kilonewton, okay, kg? I can assume anything, correct? Uh, so I have deducted 1 marks for not writing the units. Okay, many students supposed to get 30 out of 30. I found one place student missed to write the unit. I have deducted 1 marks and many more. Once I'll show you the answer script, you will get the idea more. So 3 is over. So another approach people can do, just a minute. Oh, okay. Okay. So what we can do, we can use entire sections for one value of I. Then we can consider these sections and these sections IXX value and we can subtract. So one is 1 by 12 this is the base, correct? CG location. 1 by 12 base is 4A multiplied by height cube. Height was A and A. This was 4A. 4A cube minus, I am simplifying this. For this case 2 times 1 by 12 multiplied by base. This base basically, this is 4A and this is A. So 3A by 2. Okay. 3A by 2. This is the base multiplied by height cube. It is 2A cube. That way also somebody can do. Entire 1 by 12 multiplied by this entire one. Entire this square 1 by 12 base multiplied by height cube minus 2 times 1 by 12 base. This base will be, total is 4A. This is A. So this is 3A by 2 multiplied by height. This is 2A cube. That way also you can calculate. Is it clear? Problem 3 is okay or should I explain once?
Okay, sir.
Okay. Now problem 4. Yes. Now calculate the value of H such that Ix and Iui will be same. So this is the H value given. So what I can do, I can divide this into 2 parts. This is 1, this is 2. You have to be careful. This is the x-axis. This is the y-axis. Okay. Now, if I calculate what is IXX value for 1 and 2 as a I will do. So IXX value will be, for 2 it is 1/3 multiplied by base 30 plus 30 multiplied by height cube 10 cube. Okay. 1 is over. 30 plus 30 10 cube. 1 by 3 base multiplied by height cube. Now for case 2, this is the centroid. Okay. 1 by 12 multiplied by base 10 plus 10 multiplied by height cube, h cube. 1, okay. Second one I am doing. 1 by 12 multiplied by base 10 plus 10 multiplied by height cube plus area. Area is 10 plus 10 multiplied by height. This is the area multiplied by distance square. Multiplied by distance square. What is the distance? Distance is 10. This is 10 multiplied by plus h by 2. This is the h by 2, is not it? H by 2. This square. This value is the IXX. Similar way, IYY will be, this is IYY. For this case, it is 1 by 12 because this is the centroid is lying on the symmetry. 1 by 12 base 10 multiplied by 60 plus 60 cube plus second case. This is passing through centroid. So it is 1 by 12 multiplied by base h height cube 10 plus 10 cube. Now equate with IXX equal to IYY. You will get one expression, some cubic term will get, some cubic term, and if you solve with positive value of h, you will be getting 20 mm. It is little bit time consuming. If you try once, first time maybe it will take some time, second time onwards it will be very easy. So what we did, we have divided the sections into 2 parts, part 1 and part 2. Part 1 IXX IYY, part 2 IXX IYY we can calculate separately. Then if we add for 1 and 2 IXX and IYY and then we equate that as the same, we'll get some cubic expressions of H and there some value will be negative. We cannot take that. H should be positive. That positive will be 20 millimeter only. And I have given the expressions. So how I have done this? IXX IXX will be for this it is base 1/3 base multiplied by height cube plus for this 2 for 2 1 by 12 base height cube plus this area plus distance square that is h by 2 plus 10 that square. For IYY, for section 2, for section 2 IYY 1 by 12 base height cube plus this also centroid is lying on the symmetry 1 by 12 multiplied by base multiplied by height cube and then equate IXX equal to IYY to get the solutions. Should I repeat or is it okay?
Okay, sir.
Okay, fine. Now, last problem for 6.2. There is a H beam. Okay, looks like capital H. That is a section. H beam section means actually it is a beam. Okay, it is a beam and its section is looking like this. I'll tell you. Section is this is the long beam. Okay, this is the long beam. And we are only dealing with these sections. Okay, this is a H beam sections. Beam is has come that this is the beam, long beam, and this H is the sections. Okay, determine the planes with B. We have to calculate the B such that will make the moment of inertia about the central x and y axis are equal. So what value for what value B IXX will be same as IYY. Okay. So here also I want to divide this into three parts. Part 1, part 2 and part 3. You can do separately. Part 1 IXX1 is 1 by 12 base is 10 then height cube sorry base is 100 this is 100 basically base multiplied by height cube 10 cube millimeter power 4. Don't forget to write this millimeter power 4. Okay, IYY1 will be 1 by 12 this is the x axis this is the y axis base 10 height cube. Sorry I did one mistake. If this is 100 this is 10 this is 10 so this will be 80 mm. So I should write 100 minus 20 here and here 100 minus 20. Okay, be careful with the unit. So IXX IYY I get part 2. Part 2 and part 3 will be same. Okay, so IXX 2 3 let it write 2 multiplied by because same distance same area 2 multiplied by if I consider this is the centroid IXX this is the centroid then 1 by 12 base 10 multiplied by height cube. Height is B here. Height is unknown that is B cube 1 by 12 2 multiplied by 1 by 12 base height cube. Yes, then IYY 2 3 that will be 2 times this one. So IYY is if I consider this as the base then 1 by 12 base is B height cube height is 10 basically 10 cube plus area 10 multiplied by B multiplied by distance square. Distance is this to this distance. Then it is 10 by 2. This is 10 by 2. Or maybe I can write directly write it is 50 basically. Okay. This two, no, just a minute. No, this is 5 and this is 8. This is 40. Okay. So what will write? 10 by 2 plus 80 by 2. Actually 45. Okay. 5 and 40. This square. So this distance, let me change the color, you will understand. So these two, sorry, color it has not taken. This to this distance, how much? Okay, this one is 5 and this is 40, 45, is not it? So we can write in exclusively this way, 10 by 2, 10 by 2, sorry, not this one, plus 80 by 2 square, whole square. Then what we can write? Total IXX, total IYY, equate that. Then here also you will get one expressions, one expressions of B, something like B cube plus say MB minus N equal to 0. That type of expression you will get. For positive value of B, you will be getting B equal to 161 millimeter. Once again, I would like to say, I have divided this into 3 parts and I have calculated IXX for part 1 to 3, IYY for part 1 to 3. I have added up part IXX and IYY. Then I have to equate left side equal to right hand side. Left hand side equal to right hand side. Whenever required, I have used parallel axis theorem. For parallel axis theorem, what I have utilized, I have considered first one that IXX or IYY based on the centroid location. Then I have used AD square, that formula for the parallel axis theorem. You have to be careful. Parallel axis theorem is applicable only for the axes are parallel to the centroidal axis. Number 2, between these two axes, one must pass through the centroid. Else, these equations will not be valid, because in the formulation of the parallel axis theorem, we got one integrations YdA and we have put that as a 0. That was the definition of the centroid. Hence, one axis must pass through the centroid. And we have learned that when it is the geometry is with some symmetry, then product of inertia will be 0 for that case, and centroid is lying on the symmetry axis. Any doubt up to this before moving to next 6.3? Should I explain anything you need?
No, sir.
Okay. Last chapter is product of inertia and transfer of x. For this product of inertia chapter, first of all, we know that product of inertia for any symmetry section is 0. I xy for any symmetric section is 0. We have explained that. Now we have to calculate product of inertia for this 1, 2, 3, 4 sections. Okay. So this is a this is the A, B, C, D with respect to x axis and y axis. IXY we have to calculate. So what IXY? So we know this is the XY multiplied by A. That is the maybe integration form I have not shown here. Okay, you can have this one, no problem. Okay, x y multiplied by dA. Simply I am writing x y a. This terms multiplied. Now say section 1, section A. So with respect to this centroid, it is having symmetry, is not it? There are two symmetry axes. So with respect to this point, IXY will be 0. So IXY will be 0 with respect to this product of inertia. You know it.
Yes, sir. Yes, sir. Yes,
Okay.
sir.
For this, these are the symmetry axis. It may have infinite symmetry axis. It will be 0. For
Yes,
this,
sir.
with respect to this
Yes,
axis, it will be
yes,
0.
sir.
For with respect to this axis, it will be 0. Only this. Okay. Now, for case A, IXY will be IXY CG plus distance from x axis plus area. What is area? 80 multiplied by 50
50,
50,
multiplied by distance from x axis 40
40.
multiplied by
60,
distance from y axis
60.
50. Yeah, millimeter per 4. And this is 0, is not it? IXY
Yes, sir.
is 0. Now
Yes, sir.
you calculate, you will get this value. For this case,
Sir,
yeah,
sir, DY is 60.
sorry,
60 or
60.
6.
Yeah, yeah, 60, 60. Okay, you can, sorry, 60. Fine, 60. Now, similar way, for this case, for case B, IXY will be, first case will be 0 plus its area pi r square multiplied by distance from x axis 40,
40
distance from
and
y
minus
axis
60.
minus 60. So you will get minus sign. Okay, you will get minus sign. What does it mean minus sign? Area is positive. Minus sign means x and y axis are, some one is positive, some one is negative. Now you understood, if I consider this is the x axis and this is the y axis, I am getting some product of inertia. If I consider this is x axis and this is y axis, some different product of inertia. If I consider this is x axis, this is y axis, okay, prime, double prime, then product of inertia will be different because area is same, distance are different. Is not it?
Yes,
Instead of
sir.
x, y, if I use some other coordinate axis, then this product of inertia will be different. Okay, the moment of inertia also will be different. That because that's why we are using parallel axis theorem. Okay. That's why in reality, when it is undergoing some deformation, some torsion, some bending, we used to calculate some centroid, neutral plane. With respect to that, we calculate that I value. That is the reasons many times we have to transfer the coordinate of axis using parallel axis theorem. Sometimes to get the maximum I and minimum I, maximum I and minimum I, we have to rotate also. Why? Minimum I is important because I told if I is higher value, then more resistance. I is lower value, less resistance. Now, if you have some structures, some cross sections, by mistake, loading is such that, not by mistake, in real scenario, loading is such a way that it is not that neutral axis is or plane has moved with some little weight, and that particular with particular rotation, if you consider I value is showing minimum. If I value is minimum, that resistance with respect to that plane will be minimum. The structure supposed to break with respect to that plane. That is the reasons I minimum, I maximum concept has come. I minimum is also important for us because that may be crucial while one structure will break in reality. You understood this point, correct? I minimum is important because the deflection is inversely proportional to I. Target was to set the I maximum, but I may be minimum also with some rotation. That also we need to be considered. That is the reasons to draw the more circle and all. Got this point? Okay. Have you got this point? I minimum requirement.
Yes, sir. Yes, sir.
Okay, okay. So similar way, this section also we can do. Ix, Iy, Iz. Now question number 3. Determine the expression for product of inertia right triangular area about x0, y0 axis. This is one good problem. Okay. So
Sir,
this is
question number 2 is also similar as the question number 1.
yes, yes, yes. This is same. Okay. If it is area cut out, you use minus sign. Area will be minus. Okay. Nothing else. Same thing. Area will be minus.
Understood, sir.
Yeah, yeah. So find questions. So what you have to do this problem? This problem finally you have bigger bigger value of you have portion 1, portion 2, portion 3 and portion 4. For portion 1 IXY, okay. For portion Y you can 1 you can calculate IXY, that will be without this cutout. Okay. Okay. One question is, let me tell you, IX IY also told. Maybe you may face some issue. Let me write down. So IXX will be for bigger one. You can see 1 by 12 base is for 400 multiplied by height cube minus there are 3 cutout for I. I am considering IXX. For these 3 cutout, it will be pi multiplied by 30 power 4 pi r power 4 by pi r power 4 by 4. Okay. For say for this case, okay, any one, 1, 2, okay, I will spend much time then, or else you may face some issue. You have to calculate properly. Let me do it once again. Concept will be same, but one thing involved with the I value also here. Okay. So maybe IXX will be 1 by 12 base 400 multiplied by 200 cube. This is the X and this is the Y. Okay. Now, this three case, this and this, area is same. Area is same. So minus 3 multiplied by pi multiplied by 30 power 4 by 4. This is the I value. IXX pi r power 4 by 4. 3 case we have done. Then in 3 case we have to use, maybe here I can take bracket, is cut out. Okay. That's why it is negative. Plus 3 times area multiplied by distance square. Area is pi r square multiplied by distance square 50. It is also 50. So plus 50 square plus 50 square minus 50 square. It is 50 square. This is the IXX. Have you understood this point? Due to these 3 cutout, this is with the centroidal I value and this is the A D square, that expressions. Have you understood this point? 1, equation 1. Yes or no?
Yes,
Yes,
sir.
sir.
Yeah.
Yes, sir.
Then IYY will be 1 by 12 base is here 2, wait, 200, 400 cube minus 3 multiplied by pi 30 by 34 30 power 4 by 4 plus 3 multiplied by pi r square, let it be in bracket, multiplied by 100 square. Distance is 100, is not it? 100 square. Millimeter per 4, millimeter per 4. Now, IXY will be, first of all, bigger one. For bigger one, it is 0. It is symmetric with x axis and y axis, correct? It is 0. Is not it? It is 0. IXY for this rectangular cross section without cutout, it was 0.
Yes, sir.
Okay, then you come to this one. Each one we will do this. Say it is cut out, so it is minus. First one is pi 30 square. This one multiplied by 50, x is positive 50, y is also positive, y is
200.
100. Yes. Then minus pi 30 square, x is minus 100. Oh, wait, this is 50. I should write in reverse way, otherwise it will be confusion. X and y will write. So 100 multiplied by 50. Okay. Now it is minus 100. For this case, minus 100 multiplied by 50. Minus 100, minus
Yes,
100,
sir.
yes, 50. And then pi 30 square minus 100,
Minus 50.
minus 50. Okay. Now if you calculate, you will get this value. This value, sorry, it is that one? No, no, no. Sorry. This value, what is the answer? Yes, yes, yes. This value and this value. 3 determine IXX, IYY, IXY for rectangular plate with 3 equal circular holes. Okay. So we have solved one problem also. Many times, no, we have say some wheels, some shaft. We want to introduce some of the circular hole to reduce the weight without losing its strength. Sometimes we need to have some extra groove for to make the centroid at the center. That problem also we have solved. Okay, in CG push case. Now, problem number 3, derive expression for the product of inertia of the right triangular area about the xy axis. This one. This is very good problem indeed. So, what we can do? We can consider one small strip like this, where this middle it is x, it is dx, and for elements, okay, for elements maybe this is x0, this is y0. Okay. Now dixy for this element equal to di x0 y0 plus x multiplied by y. This is y. So this distance is x, but for this element distance is y by 2 multiplied by its area dA. Dixy, this is x, this is y, di0 x0 plus elemental x distance, elemental y distance multiplied by dA. What is dA? dA is y dx. So this is 0 because for this small element rectangular sections it is symmetric. We have the symmetricity. So we have x y by 2 dA. So this is dixy x y by 2 y dx equal to y square x dx multiplied by half y square by 2 x dx. Okay. Now, for this triangle, you can see this x by y, similarity triangle, x by y will be b by h, x by y, b by h, or y equal to h by b multiplied by x, right here, h by 2b, y equal to x square dx, I, x, y, do the integrations.
Sir, h square b square by b square.
I missed, correct? Here, yes, this one I missed. Yes, thank you. So this x square dx integration is over x is varying 0 to b.
B. Yes, sir.
Yes, so h square 2b square. Here it is b cube by
B
3.
Q by 3. Yes, sir.
No, something I missed once. Wait. Here, yeah, here one I missed. Okay, it is x square by x square by y square became x square. This x I missed. This was x cube.
X
Okay,
Q. Yes, sir.
yeah. 1 minute. So half h square b square x square x dx. So h square 2b square x cube dx. Yeah. So I x y integration h square by 2b square x cube dx 0 to b h square 2b square x power 4 by 4. So 4 x power 4 b power 4. So 8 b square h square. Yes. So this way we can prove this. So what we did, we have taken one elemental coordinate system we have considered, then with respect to that product of inertia was 0, then we have just simply used xy multiplied by dA expression to get this, and finally we got the solutions. Is it okay now for this problem?
Yes, sir.
Yeah. Next problem is problem 4. Okay. Determine the product of inertia of the shaded area with respect to the assigned axis. Yeah, assigned axis is x and this is the y. IXY you have to calculate. So here is locate the center of the symmetrical area. Okay. Now, if we consider this one, these sections, one is obvious that this is symmetric with respect to this, is not it? This structure is symmetric with respect to this, that is confirmed, correct?
Yes,
Yes,
sir.
sir.
Vertical axis. Now, you look another way. If you consider this one, only this, then it seems this is that symmetric, this is the anti-symmetric we call. This is the middle portion, is not it?
Yes, sir.
Here also it is the middle portion. So as a whole, this CG is supposed to lie on this sections, horizontal, and also this vertical section. Then this will be CG location. This should be centroid, this one. First of all, vertical axis straightforward. Centroid is supposed to be on the vertical axis. Okay, along vertical axis. Now, if you consider this and this and this. This is the centroid line. For this is the central line. As a whole, this line, horizontal and vertical lines show this C will be symmetric. You have learned in centroid chapter also. You can check that C will be symmetric, centroid. You can prove that. Okay, from our our observation, C is the symmetric. We have to write in words why C is symmetric. Okay, don't need to write in expression. In what you have to write. As the structure is symmetric with respect to vertical axis passing through C, CG will lie on that. For the left two triangle, if we consider, CG will lie on this horizontal line, right side also. So similar way, if you consider all four parts, then CG is supposed to be at the C location. You have to write these words. Okay, don't so somebody. I have given one problem that the task problem. I think D and EF. Somebody wrote this is zero. You have to prove that is zero. How can I know that this is zero? You have directly you have written DF and EF. I think D and EF. Those are zero force number. I cannot rely that unless if you are writing the expression or writing some word. Nothing, no explanations. So students didn't get the marks for that portions. Okay. Anyway, so we understood this is the centroid locations. Now, if this is the centroid location, then this IXY will be IXYC with respect to C plus area. Area is, what is the area? For this case, area is, it is 4 times, 4 times,
Sir, it's been too long.
which one? No, I will give another 10 minutes, not more. I cannot come back for this statics part before exam. Okay. I don't have time. So it is 4 times half multiplied by base multiplied by height. So we can get the area. Then distance. Okay. Then distance from this axis and this axis. From x-axis distance is 40. From y-axis minus 50. You put this, you will be getting this value IXY. Now, question 5. Okay. Question 5, you can split this. You can split this way. You have 1, 2, 3, 4. 4 parts. Now, you take this part, this one, part 1, and you can prove that what is the value of IXY. And with respect to x-axis, respect to y-axis, for individual one, you can, this is with respect to CG, it is 0 IXY. This IXY you can calculate from this. You have to do this, do yourself. This one. Then similarly this, you will get these results. Next one. It is been given this section, you have to calculate IA, I max, I min and alpha. Okay. Now, this IXX will be 1/3 multiplied by base is 2A multiplied by height cube. IYY, with respect to this I am considering, IY will be 1/3 multiplied by base multiplied by height cube. And these two are same. So write 2 times of this. 2 multiplied by of this. 2 multiplied by this. IXY. Okay. You consider this is the center. This is the center. It is 0 plus area 2A multiplied by A multiplied by A by 2 multiplied by A. IXY. Now, finally we will get IX 4 A power 4 by 3, IY 16 A power 4 by 3 IXY 2A power 4 unit or L power 4 you can write. Okay. You can see IXX is lower than IYY. Now if I draw the mode circle, this is the I. So this is IXY, this is IX is 4 A cube by 3, A power 4 by 3. IY is this, better, higher value, 16 A 4 by A power 4 by 3, and IXY is, this is IXY is 2 A power 4. If you have this center, draw one more circle, draw the circle like this, draw the circle like this. So you can check, wait, this is I mean, this is I max, this is IXX, this value is IYY. Okay. Now, if you consider this is a theta anticlockwise, so some theta or alpha, 2 alpha actually here. If you vary, you will get here I minimum. Here it is I maximum. Now you have to be careful that to calculate that, anybody can write this I max equal to IXX plus IYY by 2 plus square root IXX minus IYY by 2 whole square plus IXY square, and I minimum, this will be negative, at tan 2 alpha will be minus 2 IXY IXX minus I. You just put it value, and you will be getting alpha value. Alpha value will be, you will be getting 2 alpha will be getting 45 degree, alpha will be getting 22.5 degree or 112.5 degree for maximum and minimum value. But which one is maximum? Be careful. This is the IXX value, and this value is lower value. Rather than if you have to move this to this to this is the higher value. When it is lower value will be 22.5 lower value. Higher value will be 115. But this lower value is corresponds to minimum value. You see the mode circle. Look into mode circle. Lower value is the minimum one. Higher angle is the maximum value, I max. So in this question, it has been asked, from the formula you can get I mean, I max, and you have to tell the value of the alpha with the x-axis, which is making maximum moment of inertia. That will be this angle, higher value of alpha, that is 112.5 degree. That alpha will be for I max, but 22.5 degree will be for I minimum. From where we got? Because this IXX value is lower value than the IYY value. So mode circle, draw mode circle and do this. Last problem now. Determine the maximum moment of inertia about an axis passing through O with the angle alpha. This axis triangular, as triangular shown, construct the mode circle. So so what you can do to start with, that you know this IXX equal to 1 by 12 base height cube. IYY equal to 1 by 12, sorry, base is given here. Base is 100, height is 200. 1 by 12 base is 200, then 100 cube. That we know. But what about IXY? IXY is related to B square H square by 24, which I have not shown you before. I am showing here. I want to prove this. IXY for this case equal to B square H square by 12, where this is X, this is Y. Don't be confused. If somebody has given this figure, IXY will be different. For this problem, how we can get this value? Then what we will do, let it have some small step like this. Small step, this is the centroid, this is x0, this is y0. Then what I'll write, This dIXY equal to dIX0Y0 plus area. Area is, this is X dx, this is Y. Area is Y dA, sorry, Y dx multiplied by distance. Sorry, Y dA, Y dx multiplied by distance X multiplied by Y. Now, from the similarity triangle, we can write that Y by H, actually 200 here, equal to 200, actually Y by H equal to 100 minus X by 100. Okay, because this is X here, so this is 100 minus X. So we can have relationship between Y equal to 200 by 100, 200 minus X. That relationship we can use from this. And so what we can do, we can replace this Y by, in terms of X, X is already there, dx is there. So if you do the integrations, we'll be finding this value, ixy equal to b square x square by 24. Homework you do at your own. Now once you will get, so you will get ixx, iyy, izz. Sorry, ixy. I'm simply just writing this 66 0.67 10 to the power 6 millimeter per 4. 16.67 10 to the power 6 millimeter per 4. Here also it is 16.67 10 to the power 6 millimeter per 4. You can see Ixx is higher than the Iyy. So if I draw the mode circle, this is I, this is Ixy. So this is 66, sorry. So this is a 66 and this is 16, this is 66 and say this is say 16. Then what we can do, we can have the center, this is Ixy, and we can draw mode circle. This most geometry box you can use for the mode circle. So what we will get, this is the center, this is the I minimum, this is the, sorry, this is the Ixx, this is, sorry, this is Iyy. Just 2 minutes. This is, just a minute. Just a minute. So this is I minimum and this is I maximum. And if I draw the mode circle with this one, you can see to get the maximum value, this is theta or maybe alpha. Alpha, it is clockwise. If it is clockwise, it will be negative. If it is clockwise, it will be negative. Anti-clockwise will be positive. And you can see for this Ixx, if you move only this, you will get the maximum value. So this value is less than 90 degree. So if you solve this, and you use the expression same way, this is center, then center plus radius, or simply if you can utilize this Imax expression, then you will get this Imax value as it is been given as 71.7 10 to the power 6 millimeter per 4, and alpha value will be getting minus 16.85 degree. Okay, that's all guys. Any questions do you have?
No, sir.
Yeah.
No, sir. Actually, this
Yes.
6.3 is yet to be complete, sir. Let us complete, sir.
Okay, this is done. I have solved everything. I
Okay,
have
sir.
given the hints. You do at your own. If we get time, then April 1st we can discuss. Not before that. April 1st.
Okay,
Okay,
sir.
sir.
Because I am in a very tight schedule. Okay, let me check the attendance quickly. I can take the attendance. Just a minute. uh, uh, this is aerospace 25 is absent, 26 present, 27 present, 28, 29, 30 present. Then civil 77 present,
Yes, sir.
7.
Hello, sir.
Yeah.
I'm Civil 77, sir. In the previous day, I was present the whole class, sir. Actually, after sir 5 p.m., I got my
Okay,
network
okay, no
connection
problem. No,
something
I
unstable.
am giving attendance, no issue. Then 79 present, 80 present,
Yes,
8, 81 is absent, 82 present, 83 present, 84 present, 85 is absent, 86 present, 87 present, 88 present, 89 is absent, 90 present, 91 absent, 92 absent, 93, 94 absent, 95 present. Okay. CST 58 absent, 59 absent, 60 present, 61 absent, 62 absent, 63 absent, 64 present,
Sir,
Six-
62 present.
62, 60,
Sir,
CSB.
61 also present.
61 present, 62 present, okay, 64 present, 65 present, 66 present,
Sir,
67 present,
actually, I was present in the last class, but
okay, 66,
due to
huh?
some network issues, I couldn't
Okay,
stay.
okay, okay, okay. 69 present, 68, 69, 70 present. Then electrical 49, 50, 51 absent, 52 present, 53 present, 50, 54 absent, 50, 55 present, 56 present, 57 present, 58 present, 59 present. Then electronics 35 present, 36 present,
Sir, I was
thir-
present in the last class also.
okay, 36, okay,
Yes.
36, 37 present, 38 present, 39, 40, 41 absent, 42 present.
hello, sir.
Then, yeah,
Sir, I was present in the last class.
okay, understood. Okay, then IT 53 present, 54 present, 55 present, 56 present, 57, 58, 59, 60, 61, 62, 63, 64 present. Then mechanical, mechanical 60 present. Just a minute. Mechanical, there is something issue. Mechanical 50 present, 51 absent, 52 present, 53 present, 54, 55, 56, 57, 58, 58, 59, 60 present. Then metallurgy, metallurgy 25, 26, 27, 28, 29 present, 30 absent, mining 26, 27, 28, 29, 30, okay, 20, just a minute, who is absent? 25 is absent, mining 25 absent. And okay, those who are absent once again, aerospace 25, then civil 81, civil 85, then civil 89, 91, then civil 94, 50, computer science 58, 59, then 50, then electrical 51, electrical 54, then mechanical 51. That's all. Oh, another student is mining 25. Okay, fine. So next day, next week, I will start new chapters. That is dynamic. Reference is same. Author Miriam and Craig, Volume 2. I will get only 7 days to complete the syllabus. Okay, so be prepared if you want to take some prior preparations for understanding. You can do only 7 days left, 9 problem sheets. So I am in a very tight schedule. Okay. Okay, guys. Thanks for your patience. Okay. See you next week. Bye. Bye.
Thank
Bye.
you, sir.
Bye. Bye. Bye.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.